vector line integral. Oh, by the way, do you guys notice that this format is a little different from the FDR, but you're kind of used to both formats now. This is just F here is, that one is the X component, that one is the Y component, and that one is the Z component. That's all it says, basically. That's if you want to match. Then there are two pieces. Let me see if I can write this cleaner than the last time. So there is a C1 that goes from 101 to 231. And there is a C2 that goes from 231 to 252. Again, I'm using that same time because it's a line segment, line segments, right? Line segments, that's the formula that I use for it. What is the formula? The formula is A plus TAB. Here A, here B, here A, here B. So R1 of T is going to be the first point plus T, the difference of the two, which is going to be 1, 0, no, 1, 3, 0, right? Am I missing something? No. And so if I put them together, I get T plus 1, I get 3T, and I get 1. Then we have R2 of T equal to 231 plus T times the difference of the two, which is 0, 2, 1. So that is 2, 3 plus 2T, and 1 plus T. Parameterization is done. For vector line integral, I need the R prime, right? I don't need the magnitude, I just need the R prime. So R prime, step 2, R prime of T is going to be what? R prime of T is this. What multiplies T? That's just for the basically. Step 2, R prime of T. Oh, this is R1 prime, R2 prime. Is that 0, 2. Then I need step 3 for the first line. Step 3, just plug in parameterization into here, which is going to be f of R1 of T is equal to X plus Y times Z. It's T plus 3, T plus 1 plus 3T, 2Y, which is 6T, XYZ, which is 3T squared plus 3T. Then step 3 is f of R2 of T equal to, now there is X plus YZ, here X over here plus YZ, 5 plus 2T. God knows I'm going to make a lot of error in here. It's a lot of algebra to remember. And then I multiply XYZ, which is, I'm going to write it down here. It would be 2 times 3 plus 2T times 1 plus T. All good? I think so, right? Now, the last step for all of them is to multiply and integrate. So dot product The dot
With
product,
GR?
yes.
Someone
one?
pointed out in the chat that the y component for your f is 2x, not 2y.
Oh, isn't it 2x in the y component? Oh, you're right.
It's 2x, but you wrote 2y.
Oh, God, sorry about that. It's a 2x. So 2 times x, which is 2t plus 2. Here is 6 plus 40. There we go. And then, thank you. Thank you, Uzaifa, for keeping me checked. It's difficult, by the way, to yell it from the crowd here. It's just, everybody's masked, and so it's kind of difficult. I kind of wonder if we could put like a few like microphones through the crowd, because it's just not, your voices does not go through. So if I do the dot product, I will end up with dot product of first one. Again, 0 to 1, because how I parameterized was the line segment parameterization. That is nice. I get 40 plus 1, and then I get 60 plus 6 pt. And then for the second one, I get 0 to 1, and then 12 plus 80 plus 2 times 3 plus 2t times 1 plus t dt. And then you compute. And then you add them together and add. So that was the major part of this. They become a routine when you do a couple. It's just you have to remember if it's a line integral, if it's a scalar line integral or vector line integral. You have to remember what point start, what point ends, that sort of things, basically. It's just not a whole lot. And then it doesn't matter for the scalar line integral where you start, where you end, because you don't see the R prime in there. You see the magnitude of R prime. But for the vector line integral matters where you start, where you end. Those things to remember, basically. Everybody okay so far? Move on. Time to go? Okay, so now we get